So in this video, we are going to discuss about double summations. So these are used in the analysis of nested loops in the computer program. So suppose we have this double summation. Okay, so we have the sum of I equals 1 to 4 of the summation of j equals 1 to 3 of ij. So we can read it like for I equals 1 to 4, take the sum of the product of I and j. Okay, so this inner summation is nested within this outer summation. So translating that into code, we have this block of code. So suppose we are taking the sum. So we have initializing the variable sum into 0. And first, this outer summation may be written in this loop. So we have 4 for I equals 1. So that will be the lower limit, I equals 1. And iterating through all the values of I until 4, then I plus plus. Okay. And for each value of I, we take the summation of, or convert this inner summation into code. So we have for int j equals 1. So we also have the lower limit for j equals 1. And iterate through all the values of j until 3. So j is less than or equal to 3, j plus plus. And we take the sum of the product of I and j. Okay, so the second line of code will be equivalent to the outer summation, and then the third line, the second loop will be equivalent to the second summation. Okay, and then the last line, the sum of I times j, or I times j is equivalent to this expression ij, right? So to evaluate the double sum, we must first expand the inner summation and then continue by computing the outer summation. So first, let us expand this inner summation. So we have j equals 1 to 3 of ij. So we have, if j is equal to 1, so that will be equivalent to I. If j is equal to 2, so that will be 2i. Okay, if j is equal to 3, so that will be 3i. So this is the inner loop. This is the expanded form of the inner loop. So I plus 2i plus 3i will be equivalent to 6i. So now let us evaluate this outer summation. So the sum of I equals 1 to 4 of 6i. So then we will iterate through all the values of I until 4. So we have 6 times 1 if I is equal to 1. Then 6 times 2 if I is equal to 2. Then 6 times 3 if I is equal to 3. And 6 times 4 if I is equal to 4. So taking the sum of all of these products of 6 and I, so we arrive to the value of 60. So the summation notation can be used to add some values also of a function. So assuming we have a function f of x, x plus 2. So suppose that we want to take the summation of x in 2, 3, and of x, which is of the set which is in the set 2, 3, and 5. So what will be the value of f of x? So the summation of x in the set 2, 3, and 5, f of x will be equivalent to f of 2. So we substitute f of 2 here plus f of 3 plus f of 5. So we are going to use each of these values of x as an input to f. So then we have f of 2 plus f of 3 plus f of 5. So we have this function f of x equals x plus 2, right? So if the input is 2, so that, or the x is 2, so that will be 2 plus 2, so we have 4. So if x is equal to 3, so that will be f of 3, that will be 3 plus 2, that will result to 5. And lastly, if x is equal to 5, so we substitute the 5 here, so that will give us 5 plus 2, which will result to 7. And summing this all up, this will result to or evaluate to 16.